we're going to do is we're going to find the limit as x goes to a number c. So first we're going to do examples graphically. So here the first graph is f of x, and we're going to find the limit of f of x as x goes to 0. So first what we have to know is what's a limit. So what we're going to find a limit is the x value. So we're going to find as x gets closer to 0 from both positive and negative side. So as we go from this side, as it gets closer and closer to 0, the y value gets close to 2. And if we go from this side, it gets close to 2 also. So what we're going to do is we're going to find the limit of f of x as x goes to 0. So in order for the limit to exist, both sides have to go to the same y value. So if we look at the positive side, it goes towards 2, and from the negative side it goes also towards 2. So the limit here is going to be 2. Let's look at another example. So this is a piecewise function. So we're going to find the limit of f of x as x goes to 2. So if we look at x2, we have this graph, which the y value is 2, and we have this graph, which the y value is 1. So we have to find as the limit of g of x as x goes to 2 from the positive side, and also the limit of g of x as x goes to 2 from the negative side. So to find the limit of g of x as x goes to 2 from the positive side is going to be this one, and that is going to equal to 2. The limit of g of x as x goes to 2 from the negative side is going to be 1, which means that the limit does not exist for g of x as x goes to 2, because we have two different answers, so it does not exist. Okay, so basically for a limit to exist, as the x values get closer to 0 from both sides, the y value gets closer to 2. This was for the first example. So, and the limit is always the y value, and for the limit to exist, both sides have to go towards the same y value. So we're going to look at it numerically. So for that, we create a chart. So we have a function, f of x equals x to the power of 3. So we're going to plug in 4, and also we're going to plug in x values around it that are really close to it, so we really see what happens around 4. So if we plug in 3.9 here, it's going to equal to 59.3. If we plug it 3.999, it's going to equal to 63.95. If we plug in 4, it's going to equal to 64. If we plug in 4.001, it's going to equal to 65.04. So we can see that as x goes towards 4, that's why we want to find the limit of f of x as x goes towards 4. At 4, it's 64, but we want to see what happens around it to see if the limit exists or not. So we can see that this number gets closer and closer to 64, and this one also. So we can say that the limit of f of x as x goes to 4 is 64. Let's do another example. We have this function, and we have to find the limit of g of x as x goes to 3. So if we plug in 2.8, we get 0.044. If we plug in 2.999, we get 0.042. If we plug in 3, it does not exist, which means there's a discontinuity. If we plug in 3.001, we get 0.042. And if we plug in 3.1, we get 0.041. So we can see that as x goes towards 3, it gets closer and closer to 0.042. However, we can't see the the decimals are after that, but we can see that the graphic is continuous, which means the limit exists. So the limit is going to be in between that, which is also 0.042. We could add all the decimals that go after, but the most important one is these numbers. The last thing we're going to find is the limit we're going to find it analytically. So we have the function f of x equals 5 minus x, and we want to find the limit f of x as x goes through 4. So what we're going to do is we're going to plug 4 in and see what we get. So we've plugged 4 for x, and we want to find what this gives us. So 5 minus 4 equals to 1. So the limit of f of x as x goes through 4 equals 1. The last thing we have to know is removable, if the discontinuity is removable or not. So you can remove discontinuity when the limit exists at that x value. So for example, we have this graph, so the discontinuity is at 0, and since the limit doesn't exist at this x value, that means it is not removable. Let's see this one. At this one, the limit exists because on the right side and the left side, the function keeps on going, which means that the limit exists, which means that this point of discontinuity is removable. Okay.